Hi guys, so let's look at section 8.4. I'm going to make a separate video for you about this to show you the definition, but just suffice it to say that basically the foci, or the two focuses, the foci are the 2 points that form an ellipse, and the way they form an ellipse is that every point on the ellipse is d1 plus d2 equals a constant away from the foci. Okay, so if this is a point on the ellipse, let's say this point right here, then this distance plus this distance, if this is d1 and this is d2, must be the same as this distance plus this distance. Okay, and that's why they say constant. So if d1 plus d2 is 5, then for every point on the ellipse, d1 plus d2 must be 5. Okay? And I'll try and make you a separate video to show you that illustration using GeoGebra. Okay? Alright, so I'm just going to walk you through this. The line through the foci intersects the ellipse at the two vertices. And then, okay, the line through the foci, here's the foci. The line through the foci intersects the ellipse at the two vertices. Okay, so these two are called the vertices. And that's called the major axis. This right here is called the major axis. Right there, the major axis. Okay? And then the midpoint is the ellipse's center. So from here to here, this is the midpoint. Okay, the center of the ellipse is the midpoint. In other words, this distance is the same as this distance, and that distance is called A. Okay, and then the line perpendicular to the major axis. So let me use yet a different color. This line right here is called the minor axis. Okay, the minor axis, and it's perpendicular to the major axis, and where that axis touches the ellipse, those 2 points are called the co-vertices. Okay. Okay, so that's the definition there. Naturally, we are doing algebra here, not just geometry. We are doing analytic geometry. So we want to talk about equations, and so you can see that there's two different types of ellipses. One is what we can call a horizontal ellipse, the other one is a vertical ellipse. And how would I know the difference? Well, the difference is where the major axis and the foci and the vertices are. So if the vertices are on the y-axis, then the equation looks like this, and we call that a vertical ellipse. And if the vertices are on the x-axis, then the formula or the equation looks like this, and we call that a horizontal ellipse. Okay, and so that's basically how this works. I don't want to spend too much time going over this because it might just confuse you. I think it's easier if we just jump in and do some stuff. Just suffice it to say, to graph an ellipse or to understand an ellipse, I need to know where the vertices are, I need to know where the foci are, and I need to know where the co-vertices are. Then I can graph it, but remember from the definition, the foci are crucial because the foci are what make up the ellipse actually. The ellipse comes from the relationship between the foci. Okay, and just remember that this is the center for all of the ellipses we're doing in this section is 0, 0. It's the origin, and that the center bisects the major axis, the minor axis, and the distance between the foci. Okay, and the variables are very important. If it's a vertical ellipse like this, then the a squared is under y. If it's a horizontal ellipse like this, then the a squared is under x. And there's another relationship that you must remember. A is always bigger than b. So if you're looking at it, which will mean that a squared is also bigger than b squared. So when you're looking at the equation, if you're given an equation, then you can quickly recognize if it's horizontal or vertical by the fact that a squared is bigger than b squared. So the number that's bigger, the variable that it's under, will indicate for you the direction of the ellipse. Okay? And then there's another big equation that you have to have for ellipses, and that's this. This basically says this has to do with the foci, this has to do with the vertices, and this has to do with the covertices. Okay. In other words, the square of the distance from the center to the focus, that's this, is equal to the square of the distance from the center to the vertex minus the square of the distance from the center to the co-vertex. Okay, so yeah. Any case, this is an important equation. You need to know this for sure to be able to do anything to do with ellipses. Okay, so I'll let you look at that. They give you some more information here, but I think I've pretty much covered that already. Also, what I would suggest you do for yourself is go through and just review all the equations and formulas you've learned until this point. We actually did basically about 5 or 6 different formulas from Algebra 1. The new ones we've learned so far this year are for parabolas. Okay, for parabolas in this chapter were 2 of them, x squared equals 4py, or y squared equals 4px. And then the other one we did was for circle, which is x squared plus y squared equals r squared. Okay, and today we add these 2 formulas to our repertoire of formulas. All right. Okay, so let's leave it at that and jump in and do some examples. So example 1 says graph the equation, identify the vertices. So this is what you have to do. Identify these 3 things on my graph. Okay. Now, I look at this and I go, I don't know what this is because it doesn't look like the formula for an ellipse. This is what the formula for an ellipse looks like. So it's not in standard form, so I have to put it in standard form. So, if I have something like this, okay, or I have something like this, could be that a squared is under y and not x, okay, I need to make this equation look like either of those 2. Now the way you do this is focus on the 1. Both of them have a 1. I don't know off the bat which one is a or b, but I know that the equation must be equal to 1. So the way you can do that is to divide this by 100. If I divide this by 100, then I get equal to 1 over here, which that's what it's supposed to look like. And then I can just reduce the fractions. So 4 goes into itself once, 4 goes into here, 25, 25 goes into itself once, and 25 goes into 100 4 times. Okay? So this is what I have then. Basically, I have this equation, x squared over 25 plus y squared over 4 equals 1. Alright? Okay, so now I have something that looks like one of these, and I see that this number is bigger, so I see that it looks like the first one, which means if, let me erase all this writing, it means if the number under x squared is bigger, then it means that it's a horizontal major axis, a horizontal ellipse. Okay, so the bigger number is what we call a squared, the smaller number is what we call b squared, and I can use that to totally draw my ellipse. So a is the number that's associated with the vertices, so a squared is 25, and if I take the square root of both sides, you get a squared equals, a is plus minus 5. So again, because a is under x squared, then I know the vertices are on the x-axis, and remember for this section, all our ellipses are centered at the origin. Okay, so I'm going out to 5, and I'm going back to negative 5, and those are my 2 vertices. Okay, those are my 2 vertices. Let me do this in a different color. Then I do b squared equals 4, and that means that b is plus or minus 2. But now b represents the covertices, which is on the minor axis, which is perpendicular. So that would mean b is 2 means here, and b is negative 2 is here. Okay, 2 and negative 2, and these would be called my covertices. And this is the minor axis, and this is the major axis. Okay, So major axis here and minor axis in red. All right, at this point you actually have enough information to draw the ellipse. You can draw the ellipse. There it is, sort of. My ellipse is ugly, forgive me. And then there's something missing though. We did vertices, we did co-vertices, we need foci. Okay, remember, actually the ellipse is defined by the foci. So that, don't forget them, they're not like some add-on, they're actually the thing that makes the whole ellipse work in the first place. Okay, and so the way you find that is to say, to use this formula again that was given to you here. The focus and the vertex and co-vertex are related this way. Okay, so you do c squared equals a squared minus b squared, and you say c squared is 25 minus 4, so c squared is 21, and then you take the square root of both sides, so c is plus minus root 21, and we want to approximate that, and if you do the approximation, I think what you get is about 4.6. Okay, 4.6. So the foci are on the major axis, so 4.6 is about here and about here. Okay, and there are my foci. Okay, and students always ask, what's the minimum work I can do? This is the minimum work you can do. You must at least show how you found your vertices, your co-vertices, your foci, and then you can draw the graph. Okay, and also of course that the equation was put in standard form, otherwise you can't do this properly. Alright, I'm not going to do B, you can do B. Let's do C, because C is a vertical ellipse, and at least you have seen one of each. If you want to do B and D, feel free. If you feel comfortable, don't do them. Okay, so let's do letter C, and this one says 49 here and 36. So 49 is bigger than 36, so the bigger number is A. So this is my A squared, and this is my B squared. Okay? And that means that since the bigger number is under Y, my major axis is going to be the Y-axis, so I'm going to have a vertical ellipse as opposed to a horizontal ellipse. Okay? And so all I'm going to do is again do the math to find what A is. A squared equals 49. So A is about plus minus 7. And because A squared is under Y squared, then I know that this is a vertical ellipse, and so it's going to be up here at 7 is my... Wait, I've got some residual erasing here. That's interesting. I've got plus minus 7 up here, 7 and negative 7. Okay, so these are my vertices. Okay, that means that this is the major axis again. Major axis is here, so the foci should be on that axis too. Okay, and then let me use a different color. Let's do b squared then. B squared is 36, so if I take the square root, I get b is plus minus 6, and that would be on the perpendicular minor axis will be at 6, so maybe here and here. Okay, and so these would be my co-vertices, okay, and then again this is the minor axis right here, the minor axis which is perpendicular. We said all this stuff. The center is the origin for all of our ellipses in this section. And remember that the center bisects the axes. Okay, so these distances are the same. All right, and you can draw your ellipse. Let me use green. I can draw my ellipse. Looks like this. Okay, and then the missing part are the foci, and so I have to do c squared equals a squared minus b squared, and I just do the math. Okay. So a squared is 49, b squared is 36. That means c squared is equal to 13. So c is plus minus root 13. And if you do that math, what was that number? Root 13 was about 3.6. Okay, was about 3.6. And so 3.6. I'm going to zoom in to draw that. 3.6 would be 1, 2, 3.6, like maybe over here. there's a focus, and then down 1, 2, 3.6. So maybe over here there's another focus. Okay, and so again, you did your vertex, co-vertex, foci, and you can draw everything, and you're done. Okay, difference between this one and the previous one, I did not have to change the formula, it was already in standard form. Like D, I'm going to have to change, it's not in standard form. Okay, alright, so that's how you graph an ellipse if you're given the equation. This is the opposite question. I'm given the vertex and the co-vertex, and now I have to write the equation of the ellipse. So write the equation if they give you the vertex and co-vertex, and we know that for this section the center of all of our ellipses are 0, 0. Alright, so they gave me the vertex and co-vertex. So they gave me this, and they gave me this. Okay, the difference here is I have to figure out, is it a vertical or a horizontal ellipse? Which formula am I going for to write my equation? Which formula? Okay, and so what you see is the vertex is a y coordinate, and so that tells me that A is 4. Vertex goes with A, co-vertex goes with B, always. Okay, and so that tells me that this is an x coordinate, and that tells me that B is 3. Okay, I'm 3 away from the center. -3 is the coordinate, but the distance is 3. Okay, so since the vertex is on the y-axis, I know my formula looks like this: x squared over b squared plus y squared over a squared equals 1. Because my vertex is A, and that's on the y-axis. Okay, and so what I can do now, I have A, I have B, I can plug it in and I have the answer. It's very quick actually. I have x squared equals 3 squared plus y squared over 4 squared equals 1, and so you just have this. Okay. This is one way. I'm gonna leave that one like that and assume that you followed along and you're happy. But just in case you're not happy, I'm going to do letter B differently. So if this didn't work for you and you're going, wait, I didn't track with that at all, then I would say draw a picture. Okay, so I'm gonna do another example, letter B, but this time I'll draw a picture and maybe that'll make more sense to you. Okay, so if you draw a picture, I'm just gonna draw axes there, X and Y. And I'm going to draw the picture. It says the vertex is at 0, -7. 1, 2, 3, 4, 5, 6, 7. So -7 here. So this is a vertex. Okay. Well, the vertex tells me what the major axis is. So the other vertex must be up here at 7. Okay. And so that tells me that this is the major axis. This is the major axis. Okay, because the major axis connects the vertices. Well, if the major axis is vertical, then I have an equation, and then that tells me that this distance is A, which is 7. Okay, and so that tells me that A goes under y squared, because I'm going in the y direction. Okay, so that tells me that my equation looks like this: x squared over b squared plus y squared over a squared equals 1, because A is in the y direction. Okay, and so that's my equation. And then the co-vertex is at 4. So let me do that, yet another color here. The co-vertex is at 4. 1, 2, 3, 4. There is my co-vertex, 1, 2, 3, 4. There's my other co-vertex. Okay, so my ellipse looks something like this. You don't have to draw the whole thing, but that tells me that this distance here is B, because A is associated with the vertex and B is associated with the co-vertex. Okay, and so the distance here, B, is 4. All right, so now I can just plug stuff in. I already know this is A, this is B, and I can just plug it in as long as I have my A in the right place. Since A is on the y-axis, I know that this is the formula I have to use. Okay, and so I just do x squared over B is 4 squared, so that's 16, plus y squared over A is 7 squared, which is 49, that's equals to 1. Okay, and there you are. That's not too bad. Again, if you can't just do it purely algebraically, a picture always helps. Okay? Alright, so then example 3 is sort of a problem-solving question, not too much. Basically it says lightning strikes, when lightning strikes an elliptical region where the strike will most likely hit can often be identified. Okay. Suppose it's determined that there's a 50% chance that a lightning strike hit within the elliptical region here. Okay, so what we want to find is an equation for that region. Alright, write an equation for the ellipse. Okay, so I would take the picture and say, alright, all we know at this point of section 8.4 is ellipses that are centered at the origin. So I'm going to say, let's pretend that we know the middle is right here, and then I'm going to say that is the origin, because that's the only thing we know about ellipses so far for this section, is that they're centered at 0, 0. Okay, and then we want to say, if that's the case, then I know that from the from the center to the edge on the major axis, this is the vertex, this would be the other vertex, and that distance would be called A, and this distance is the same, also A, because we know that the center bisects the major axis. And then this would be called a covertex, and this would be called a covertex, and this distance would be called B, this distance would be called B, because that's what we know about ellipses, okay? And then somewhere on there are the foci, alright, somewhere on there are the foci. Okay, and then what we want to do here is just write the equation. Now, it's a horizontal ellipse. It's a horizontal ellipse. Major axis goes this way. So I know that the equation has to have a squared under x because the major axis is on the x-axis. Okay, so I want x squared over a squared plus y squared over b squared equals 1. And then the question is, what is a? Well, we said a is here. What is a? Well, they gave me some information. They said this distance from one vertex to the other is 400. And if the center splits that in half, then this distance must be 200, because 200 plus 200 is 400. So then I know that A is 200, so I can write this okay, and then what is B? What's this distance? Well, if they told me that the distance from one covertex to the other is 200, then I know that if this the middle bisects the minor axis, then this is 100, because 100 plus 100 gives 200. Okay, so then this distance will be 100. And then you can just write the equation. X squared over that, I think that's 40,000 plus y squared over 10,000 equals 1. Okay, and then write the area, and now they give you the formula for the area. You don't have to memorize this, but they give you the formula for the area, and they say find the area. So the area is pi times A, which is 200, times B, which is 100. So A is 20,000 pi, something like that. And then if you approximate that, you get 62,831.8 meters squared. Okay? Not really much of a problem-solving question. I will say a lot of students struggle with this. I don't think it's too bad. Draw a picture. Turn it into an ellipse picture that you know. It's not that bad. Okay? Alright, and then lastly, let's talk about this. It says write the equation of an ellipse with the given vertex, focus, and center. So you need to find, they give you the vertex, focus, and we know that the center for all of our ellipses is 0, 0 in this section. And you write the equation. Okay? Now, this is different. They gave us the vertex and the focus. They didn't give us the covertex. So you can do this straight algebraically again, just by knowing which letter goes with which aspect of the ellipse. Vertex goes with A, focus goes with C. Okay, and so this, in this case, the A is an x coordinate, and so that means that my ellipse has a vertex on the x-axis. That means I have to use this type of an equation, x squared over a squared plus y squared over b squared equals 1, because the vertex is an x coordinate, therefore a goes under x squared. Okay, and then all you do is find the missing thing. So I have A and I have C, I don't have B. This is the missing thing. So you just do C squared equals A squared minus B squared, and then I can use C and A to find B. Okay, I can use C and A to find B. So then what I have is 16 equals 64 minus B squared. And then just take the B over and subtract the 16. So you basically get 64 minus 16. So B squared is 48. Okay? Now I don't have to take the square root, because notice the formula demands a B squared, not B. Okay, so I don't have to take the square root. So I have B squared, and they already gave me A, and I can just square A to get 64, so A squared is 64. So all I just do is say x squared over 64 plus y squared over 48 equals 1. Alright? Again, if you don't like this, you can draw a picture and then just use the picture to help you do things. Okay? So you can, let me do that approach here. Let me just draw an x and a y axis. I don't know what it looks like yet. And it says vertex is at 10, y coordinate of 10. So I'm up here somewhere and down here somewhere, okay? And that's a vertex. They told me it's a vertex. And then they said there's a focus, which should also be on the same major axis, because remember, this is the major axis. If the vertices are here, this is the major axis. Then the focus is at 8. So let's say 8 is here. I'm not drawing this precisely. That doesn't really matter. So here is a focus. Here is another focus. Okay, that means my ellipse is vertical like this, and the co-vertices will be somewhere here. I don't know what they are. We're going to find them. Okay, but if I know that my ellipse is vertical because the vertex and focus are both y coordinates, then I use a formula where A, again, A is this distance, which is 10, and C is this distance, which is 8. Okay, I have my A, I have my C, and I have a vertical ellipse, so my equation must be x squared over b squared plus y squared over a squared equals 1. Notice the difference. If the vertex is an x coordinate, then I use the formula where a is under x squared. If the vertex is a y coordinate, then I use the formula where a squared is under y squared. Okay, and so now I have to find b. That's all. I have to find b. What is this distance right here? B. What's b? I don't know that, so I have to use the formula. Same thing. I have to use c squared equals a squared minus b squared. I have c. C is 8, so 8 squared is 64. I have a, which is 10, which is 100, if I square 10. Okay, so b squared is just 100 minus 64, which b squared then is 36. Okay, b squared is 36. So I can fill it in then. I can square a to get a squared, which is 100, and I have b squared is 36. So x squared over 36 plus y squared over 100 is 1. There it is. Okay? That's all you need there. Alright guys, I hope this helps.